Ladies and gentlemen, welcome to the session. I'd like to introduce Josh Hesketh. Josh is a software developer from Rackspace Australia, working on upstream OpenStack, and while he doesn't always admit it, he's also responsible for large parts of Zookeeper. Let's give it up for Josh.
Should keep that last part quiet from Clinton. I think he's not enjoying Zookeeper, for those who are familiar with it. It's the conference management system. So that covers most of my disclaimer, which is good. I think the only other part of the disclaimer is that I'm part of Linux Australia, which oversees this conference and other ones. So if you think I got on the papers because of that, you're possibly right. Basically, this talks about guarding the gate with Zuul. Who knows what I mean by that? Just show of hand. So 3 people read the abstract. Oh, that's a few. That's good. No, that's fine. I wasn't expecting people to know. That's cool. I'm hoping that most people know what continuous integration is, but we'll touch on that anyway. And I'm hoping most people will agree that testing possibly a good idea. So continuous integration is the process of automating running your test suite at a regular basis. Traditional continuous integration looks a little bit like this. You have a developer working from a central repository where they fetch the code down, they'll do their work, they might run the unit tests locally if you've got someone who's good. They'll push it up, and then every night, or if you're lucky, maybe even after every commit, the build server will go off, check that it works, publish the results somewhere. But then it requires the developer to go look at the results to actually see, oh, I broke the system, and repeat the process. So in more traditional continuous integration, you find that developers the code is already in the master branch before you know about a problem. So code review is something that helps a lot with this, and continuous integration and code review go hand in hand, which is very similar in the sense that it's basically make sure the tests are ran before the code is merged. And before continuous integration was so prominent, it would have to be that the reviewer would download the code, run the unit tests locally, ensure that it works, and upload it. Having a robot come through and say, oh, look, there's a pull request here, I can run these tests for you and tell you whether or not it works, is a really helpful idea. And it also means that we can, the reviewer can focus more on, are the tests that the developer provided along with their changes actually exercising and appropriate for the change, and they haven't missed any kind of edge cases, and they can focus a bit more on what's important and worry about the robot to do that. Problem is it introduces some race conditions. I'm throwing up whether or not to show this on screen or like Alt-Tab to a terminal, but we'll do it on the screen. Not entirely important to read this. The bottom line is a very simple program. We have a method that goes off and fetches some data. It might be getting it from a database. It's just there on a list for now, and has a method that sorts the cities by their population. So Sydney is the largest city. The developer who started this project was very nice to us. He wrote a unit test to confirm that Sydney is the largest city. More of a functional test, really. GitHub was set up with Travis in the kind of common continuous integration that you see these days. And you often see these little build parsings on GitHub projects. It means what's in this, which is the master branch, is currently parsing. That's good. Another contributor, Jane, comes along, and she's written change to find the largest state, and it will go through the population data that it fetches and add it up. So not just Sydney, but also Newcastle and everywhere else in New South Wales. And that's fine, and she was also quite nice and provided us with a unit test. Excellent. So New South Wales, largest state. Travis was kind enough to tell us these unit tests passed in her pull request. So that means in the pull request, for the reviewer to come through, they can look at the files that have changed. They don't have to pull it down to their laptop to confirm that the tests work. They've already had that done for them. Meanwhile, another developer went off and decided we're missing some data. They happen to know off the top of their head the population of Victoria, so they typed it out. And they're like, they ran the unit tests on their local machine. It still worked. So they put in a pull request. The unit test still worked. So we've got 2 patches where the unit tests are both working. And the developer will come along and say, these look great. Or a reviewer will come along and say, these look great. I'll merge this one and I'll merge this one. neither of these are in a problem by themselves. The tests pass to begin with, and they'll continue. And the pull requests look good, but once they have actually merged, all of a sudden the build's failed, because we have a race condition where the two changes were merged in quick succession, and and now Victoria is apparently the largest state, and so the unit test that the other developer wrote has broken. So this is the process that we want to discuss today, is the process of accepting or the proposed change into the master branch, which for GitHub and most projects is a manual process where a reviewer says, looks good to me, merge. We want a robot who can understand what is going to happen better so that they can merge it for you. And that's where Zuul comes in, which we're going to be talking about. And it allows the developer to simply worry about the code and not worry about the order in which it's merging. So I'm going to take a bit of a tangent to talk about Gerrit, which is a code review platform for those who are not familiar with it. Who's used Gerrit? Oh, that's awesome. This will be quick then. Basically, just wanted to highlight this because Zuul works with Gerrit. We are working on feature support for GitHub eventually, but this is what we'll just talk about for today. That's the traditional CI kind of setup from the Gerrit documentation. Gerrit kind of sits in here, so rather than developers pushing into the central repository, they're pushing up to somewhere where they can be reviewed. The reviewers are pulling it from there, making sure it looks good. Press approve, and the key part is it's submitted into the authoritative repository, so the process can be repeated again where the developers are fetching and so on. So just the code review platform, really. A screenshot of it, which I always find useful, but as most of you have seen it, you can have inline comments. That's nice. You can comment on the overall change. This looks good, this doesn't look good, and you leave it a rating. The developers can then upload a second patch in the series. But the important part up here is you have the reviewers and then a couple of what Gerrit calls labels. You could think of them as categories. Verified and code review. These are the areas that a reviewer can leave a vote. And you can see just below it says it needs verified and it needs code reviews. These are all internal Gerrit-isms, so to speak, where it requires a verified positive vote and a code review positive vote for the code to be accepted and merged. But these are completely arbitrary. You can have as many categories as you want. This just happens to be this example project. And so someone with actual merging and approval permissions can put in that plus verified and then press publish and submit. Submit is the magic command that tells Gerrit this is good to go, merge. This is the page we don't want to see, because this is the page we want a robot to see. We want a robot to say verified. Verified as in, I've run the tests, they look good. Submit as in, let's merge. So that's where Zuul comes in. And for those not familiar with Zuul, it's the Gatekeeper from Ghostbusters, hence the image. That's what it looks like, but we'll get to that in a bit more. So Zuul will test things right before they merge and only allow them to merge if they pass. So this way, if anything has changed in the master branch before a new change is approved and merged in, it'll be able to catch those conditions and fix that race. So no one else should be able to commit into chunk except for Zuul. It is the Gatekeeper. This is what it looks like in Gerrit. This is a comment stream of Gerrit. It's posting under the user Jenkins simply for legacy reasons. Ignore that. But you can see here it said, this worked for me, verified +1. This is the initial check on the change when the author first uploaded it that shows it passes the unit tests. Some reviewers have then left some comments, and generally they keep discussing it until they're happy. Then someone with the appropriate permissions has come in and left +2 and workflow +1. Again, these labels are arbitrary, and Zuul basically just watches what people are commenting on and reacts to it. Zuul knows when someone says workflow +1, which is a privileged command, to enqueue the change to be merged. So it has done that. It has run the unit tests yet again to confirm that they still work against master. Good, they do. Let's merge it. So Zuul did that verified part. That's why you're seeing the verified +2. Again, a Gerritism that's been set up to say this has passed the unit test at this point, at the point where it will be merged. Am I going too quickly? Good. So this is the Zuul architecture. There's Gerrit, which is the code review part. Zuul, which is the robot that does everything. It uses Gearman as the protocol to communicate to workers. In this case, the workers are Jenkins, a Jenkins setup, which we won't go into much detail about. What you need to know is that Zuul is the person who, or the robot who, says these are the jobs I want to run, even though Jenkins are running it, and Zuul will take the results and submit it back. So Gerrit publishes an event stream, which is things like, oh look, a patch was uploaded, a review was added, a comment, and so on. So Zuul will listen to that and say, oh good, for these types of comments, I need to do these jobs. So it'll submit the job to Gearman, which is a simple job server, to which Jenkins have said, hey, I can do that job. So Jenkins gets the job. It does the job and sends a work complete back to Gearman, who passes that along to Zuul, who collates it all, because to a particular change there may be multiple jobs, such as PEP jobs, unit tests, integration tests, and so forth, who then collates that and puts it together for a review where you all get a +1 or a -1. So Zuul has a number of concepts that are integral to how it works. The first is a pipeline. When a change is decided to be tested, it enters a pipeline, it has its test runs, and then it exits a pipeline. A pipeline, whether or not a change is entered into a pipeline is determined by the trigger. So this is an actual layout from Zuul. It's a configuration, it's done in YAML. It's saying that whenever a patch is created, I want to bring this change into the check pipeline, I'll run my tests, and then I'll take it out of the pipeline. Or whenever someone adds a comment with the string, recheck. So that's just a way of telling the robot, do that again because you screwed up. It will then leave a report back to Gerrit or something else at two different stages. First when it begins, so this is just clearing its verified vote to 0. If it succeeds, it will leave a verified vote of +1, and if it fails, it will leave a verified vote of -1, and additionally send an email to me. The next thing that you configure in Zuul is each of the projects. So each project has a set of tests, and the tests can be different depending on which pipeline it is in. And that's what's defined here. So when the client side of the project enters the check pipeline, it'll have those 3 tests. Gate pipeline, it runs a couple of different tests and so forth. And so the server side of the project has a couple of different tests. So Zuul currently supports 3 triggers, which are Gerrit, Timer, and Zuul. Gerrit is what we've seen so far. When a patch is created, run some jobs. Timer is, oh, it's midnight, run some jobs. Zuul is an internal mechanism where, oh, you just merge something, run some jobs. It has 2 reporters currently, Gerrit, which is used to leave reviews, and SMTP, which is used to email people. It can also have a set of requirements on a pipeline where you can say only allow jobs that have no negative comments from reviewers to enter this pipeline. So that's just something you can do to constrain where Zuul will decide to test. We want to add GitHub, as I mentioned, and it will act as both a trigger and a reporter down the track. Now, the second type of pipeline in this example is what we call a gate, and this is the important one. The reason it's important is because it has the submit true. That means once this job has succeeded, or once a change has succeeded in this pipeline, Zuul will report back to Gerrit, submit, therefore merge. This is triggered on workflow 1, which is something that only an authorized reviewer can leave. So that's what we saw before. A reviewer will come through, they'll leave workflow 1, Zuul will go away and test it one more time and leave a submit. And for those who are paying attention, the 2 pipelines that I've shown you were actually different. There was an independent pipeline and a dependent pipeline. Now the reason that they're different is that when you're first incurring changes to be tested, so when they're initially uploaded, you want to see how they operate against master. However, once you've gone, this looks good to me, I want to merge it, it goes into a dependent pipeline. The reason being is that if a developer comes through and says A looks good to me, and another reviewer comes through and says B looks good to me, you can't have them both go onto master, so B will be tested after A. This is good, but the catch is if your unit tests or integration tests take an hour or 2 to run, which they often do, you can only merge half a dozen to a dozen patches per day. So the thing that Zuul handles very well to both eliminate the race condition of quickly enqueued changes and also do it in parallel is parallel testing. So for changes A, B, C, D, and E, A will be tested against master, B will be tested on top of A on top of master, and so on. So that's what E will look like. It'll be tested on top of all of them. And off Zuul will go and actually start testing all these tests in these different states. A and B have succeeded. That's good. Now, if B succeeds before A because its tests were somehow faster, it will wait around for A to finish first to ensure that A is merged into master first. So the order that the changes enter the dependent pipeline is the order that they leave, even though they're being done in parallel. Then that part's important. Now, C, D, and E have failed, but we don't actually know whether D and E failed because of C or because of changes in themselves. So we've got these two changes that we don't know what to do with. A and B have now merged. We can just repeat the process again on D and E. So D will be tested directly on top of master, which now, of course, is at state B, and E on top of that again. So that is dependent pipeline parallel testing. Okay? This algorithm is called the nearest non-failing item, which you can see here. A couple of changes which have failed have been pulled off to the side so that following changes are now tested against what is expecting to be merged, i.e. the nearest non-failing item. The other ones have their tests continue to be ran so that the results can be used for developers to figure out actually why did that fail. But you can also do cross-project dependencies, and this part is very useful. In the demonstration that I showed you earlier, it was a single project with multiple commits. But often you have multiple projects, particularly in a server-client kind of a relationship, where your client may require a change to be have entered into the server first before its own functionality and therefore tests will actually work. So this is something that Zuul will support. So you can see here, this is an independent pipeline with the check queue, and yet the client part of this program is running what appears to be third. The unit tests aren't run on the other two. They're actually queued separately, probably below. It's simply a visualization of the state at which is used to test the client. So the server actually has two commits that this third Python client relies on. And that's why it looks like this. And when Zuul runs the tests, it'll check out the server at that point, which is two commits above head, and it will check out the Python client, which is one commit above the head, and test them together. And that's simply done, you probably can't read it, but it just says depends on a unique ID that is internal to Gerrit. So it pulls in the server change, which of course has a commit between it and the head, so it pulls that change into. Right, Zuul Components. The server or the scheduler is the main part which I've been talking about. This is what the configuration looks like. It's mostly boring. You need to plug it into two things. You plug it into the Gearman server, which you saw before, and you plug it into Gerrit. Zuul will also fork a Gearman process for you if you like. So all you need to do is run Zuul server and plug it into Gerrit, and you're pretty much ready to go. The layout.yaml down the bottom is simply that pipeline configuration of YAML that we saw earlier. And so Zuul server can be run as a daemon simply like that. You launch it on a server, you point it at Gerrit, away you go. The last diagram lied a little bit. There's actually a Zuul merger that lives off to the side. So whenever Zuul sees a schedule, sees a change it wants to put into a pipeline, it'll do that and run merges on it, where it'll use Gearman to communicate with another daemon, which will do the actual merging. So that's Zuul merger, which has a similar Zuul.conf setup file. It just wants to know some working directories, nothing much fun. And how to talk to Gearman, of course. So it's the same Gearman server. And it runs as a daemon, so you can make your initd file, launch that. And what the Zuul merger does is exactly that nearest non-failing algorithm in terms of the merging. It knows all the changes that are required for this change and what they're going to be looking like. So it knows to merge all the projects at that particular point. So any two projects that share a job of the same name have to be pulled in and have a ref created at that point. So the Zuul merger creates, at the point that it expects the future to look like, references that then jobs can go and clone, which of course brings me to the Zuul cloner. The Zuul cloner will do a git clone, then a git checkout of the reference that it knows. It knows the reference because it's handed to it via the Gearman work data. The reference can be something along the lines as the change ID, and therefore it knows to go to the Zuul merger and pull the change ID. So this is all the internals and not particularly important, which is why I'm kind of skimming over it. You have your merger, which you plug into the scheduler, and you have your cloner, which is the first component of your test, which means you don't actually use the typical Jenkins Git plugin to clone your project, because that's rudimentary and doesn't understand Zuul's reference system. This will be the first command in your test. Set up the working directories yourself. There's also a Zuul client, which just lets you add things into a pipeline without it being triggered, so you can automatically re-enqueue something yourself if you need, or you can show the running jobs. It's just kind of an interface into the server. And it has a status page. It looks a bit like this. This is the OpenStack status page. You can see some tests are failing, some are passing. We have an independent pipeline on the left where the first change in that list has 4 commits above it before it gets to master, and that's the state at which it's being tested. And then we have the dependent pipeline in the middle, which is assuming everything above this point will merge, except this one, except for this one, which has failed and therefore been pulled out to the side. And there's a post queue as well, which is one of those Zuul internal triggers where something's merged, so now I can run a job such as uploading to pycon-au. Right, putting it all together. This is a developer experience. In your local environment, you will check out from the master repository the program. You create your branch, you do your work on it. Hopefully you run the unit tests locally, and you can make a local commit. You then do a git review, which is simply a wrapper around git push to Gerrit, at which point Zuul and Jenkins, off they go and they do their automatic testing in the check queue over here. They report back with a +1, -1. At the same time, reviewers are going through your code and saying this looks bad, this looks good. You take the feedback, you do a git commit amend, so you're actually modifying the commit rather than making subsequent commits, which, just taking that for it as a tangent for a second, means that the actual commit that will be merged into master is much more representative of the change that you intended to make, rather than a series of fixed a typo, fixed this, fixed that was given to you in the review feedback. It's then taken, once you've made the modifications that are appropriate, you do the review process, and this loop repeats itself. Once you've kind of gone through that enough times that the reviewers are happy with their code, they'll say, okay, looks good to me, put it in the gate queue, please, to Zuul. And that's that leaving that workflow +1. Zuul then puts that into the queue, runs a test. If they pass, it does the all crucial important part of sending the submit function back to Gerrit, at which Gerrit goes, oh good, I can actually merge this. And because they exit the queue as the same order they entered, it will ensure that that race condition is not incurred. You guys might want this. How do you get this? Well, in the interest of time for the talk, to allow for questions, I decided not to show how to set it all up and configure it, because frankly it's a little bit boring and you probably have your own tools to do it. For example, you might decide that you want to just install Gerrit from apt, or you might decide that deploying Gerrit with Ansible is more your flavor. Completely up to you. The documentation how to deploy it's actually really good. The important part is you plug Zuul into Gerrit, into some sort of Gearman server, into some sort of Jenkins master. The important part for the Jenkins master, and again you'll set your Jenkins master up using apt or whatever is appropriate, is the Jenkins Gearman plugin. That's what allows it to communicate to Gearman. And just like you would for normal Jenkins jobs, you give them a name. That name just has to match the name that your Zuul is using. That's how it knows to launch jobs, and the rest should all fall together. Of course, if you want to actually see some configuration examples or things like that, more than happy to show them to you. There's some good references. There's also the OpenStack project, which you can use their Puppet modules, which will help you out a lot. But in general, that's how it looks. And as a completely different talk, another time we can talk about how to manage nodes using Nodepool. But otherwise, we can leave it there so we have time for questions.
Thank you, Josh. So, who has questions for Josh? Oh, okay.
What would be like the minimum hardware requirements for running this for a project of like medium sort of size?
Good question. OpenStack's use, which is definitely not medium, it's huge. You dedicate a server for Gerrit, but that's actually a single point of failure. Dedicated server for Zuul, also a single point of failure. Not great, but we can talk about that later. Medium to small, you might get away with, definitely for small, running the Zuul merger on the same server as the Zuul scheduler. But the reason that communicates over Gearman is so you can horizontally scale out your mergers. So you may want another box for doing that. Depends how much resource you've shown at the server. And then that's it. The rest is all Jenkins. So that depends on what jobs you're running, how you're managing those nodes, which unfortunately I don't have time to go into, how long those jobs take, and how happy you are to wait for to complete. You know, you could have a very small testing resource pool if you're happy to wait a day for your results to come back. For, you know, hopefully not that long, but yeah. Otherwise, so the minimum is really 2, one for Gerrit, one for Zuul. You could even do them on the same, but that would be probably for smaller deployments.
What operating system should people use?
Oh, that's completely up to you. And there's plenty of instructions how to do it. I would assume Gerrit is packaged for Red Hat. I'm pretty sure it is for Ubuntu. You can definitely deploy using Ansible or Puppet or whatever you're happy with. Zuul's packaged for Ubuntu. I don't know if it's RPM'd. But again, you've got your other deployment tools. It's completely up to you.
You had a question over here?
G'day, Josh. I'm used to plugging Jenkins directly into Gerrit. So how are you connecting Zuul through to Gerrit?
Zuul listens to the Gerrit stream, which is done over SSH. And I think the part that I left out is that Zuul's not really integrated with Gerrit so much as as far as Gerrit is concerned, it's operating exactly like a human or another user. It's a robot. It's pretending to be, right? So just like anyone can interacts with Gerrit over SSH, so does Zuul. It watches the event stream, it queues the jobs, and then it posts back a review. And the parameters it posts back into the reviews are available to the users depending on your access control levels. But yes, if you're already using Jenkins and Gerrit, then you have to, and you want to use this workflow, you have to drop the Jenkins Gerrit plugin and instead use the Jenkins Gearman plugin.
Any last questions?
There's one down here. Over here.
Oh.
Hey, great talk. Question I have is, you probably were waiting for it. What's it going to take for GitHub, and how far out?
Possibly less crashing would be good. We've had a bad week where Zuul has had a bug, but we fixed it, so that's nice. That's a tangent though, mostly because I'm buying time because I don't know the answer. Look, there's been a couple of changes that are done in a rudimentary style. I have a patch series that is a large overworking of the internals of Zuul, so once that merges, adding GitHub support there makes a lot more sense. GitHub treats things a lot differently as well in terms of how a pull request looks versus how a a Gerrit change looks. So, you know, there's some terminology and consequences of that we need to figure out. But short answer, I don't know. Long answer, hopefully end of the year, but I'm making up numbers, I don't know. Cool. The comment was there is Zuul RPM. Awesome.
Okay, well, thank you very much, Josh,
That's
for
all right.
coming to talk to us. And I'd like to present you with the Siegest pycon.
Thank you very much.